Oh, I love that song. So, so let's jump into it. Today, we have coordinate geometry. So coordinate geometry is very interesting, and it's actually it's one of the more applicable concepts into the world. So two places it can be applied very, very directly is in computer science and in mechanical engineering. So if you want to build anything, or if you have anything to do with computers, then it's actually very directly applicable. So let me show you how exactly it's applicable. And again, for today, if you navigate to the website, then let's go back to the website here. Let's see. Yeah, if you go to the website, I would recommend everybody to go to the notes thing at the top, all right? So open up notes. Then you'll find another page for today, functions and graphs, right? So we're going to go into functions and graphs. And then if you scroll down here, you will see applications. So there's two really cool applications. The first of all is in mechanical engineering. So what happens is in mechanical engineering, you have to build out these 3D models of anything you've built out, anything you have in real life, right? So you want to build out these 3D models. And these 3D models are built literally like the way I showed you before yesterday, right? You draw a little circle, you put two circles, draw two lines, and then you have a cylinder. So by slowly increasing that, you get complex models like these. You guys can watch that video on your own later, but let me also show you the, on the right side, you will see this person, right? So this person is drawn, if you notice the shapes, this person is drawn using different equations. So you'll notice the circle, this is a circle equation here. Then this is a quadratic equation. This is an x equal to y line. This is y is equal to 1 line, right? This is x to the power -1 line. And this is x to the power -2 line. Here's a cubic, right? But so the point is this drawing is made using very simple equations. And so actually whatever you see on the page, like on this page, be it, let's say like these letters here, or this shape here, or whatever, you know, like this shape here, like all of these are built up of smaller and small equations. And at the back end, it's either graphing these or just keeping the individual points. So like even this square shape over here, it's all equations. And if I resize it, right, if I go bigger, you will notice the squares are going bigger and these shapes are going bigger, right? So there is a way of storing this as an equation such that this becomes easier to show on the computer. So for that reason, coordinate geometry is actually very, very important. And the other thing that's very important for is in engineering, let's say I draw a circle here, okay? So I have this circle. Now this circle, if I don't tell you anything, if I just say there exists a circle, this circle can be anywhere, right? This circle can be here, 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 or it can be a different size, right? We can change the size of the circle. It can be literally anywhere. Now, let's say I give you one constraint. And the constraint is it has to touch x-axis. Okay, so that means this circle has to be here. Then can you think about how can the circle change but still satisfy this constraint? So this can change by moving left or right, correct? We said touch, not cross. So this is not, up and down is not possible. It can only be here, but it can move left or right, and it can change in size, right? It can go, it can be bigger or smaller, correct? All right. Now let's say I say to touch y-axis, right? So then it's touching the x-axis and it's touching the y-axis. I want you to put down in chat, do you think it's possible for this circle to still change? Can I still change the circle and still satisfy these two constraints? Think about this for a second. So you can put down in chat. Nice, okay, good. All right, most of you are saying yes. Exactly, so if I decrease the size of the circle, you will notice it's possible for the circle to still touch both axes, but still it's a different circle now, right? So therefore, I need a third constraint, which in this case is radius, correct? So if my radius is fixed over here, then there's no more, I cannot change the circle any further. Or actually, or can I? Interestingly, can I? I want you guys to put down in chat, can you think of another way I can change the circle such that my circle touches x-axis, touches y-axis, and the radius is fixed? Can you think of a different way I can do this? Yeah, okay, so if you're getting this, then this can also be here, right? I'm still satisfying all these constraints, right? Mind blown, right? Isn't that cool? Yeah, so anyways, this fundamental piece, this constraint aspect can be applied to a lot of different things. And you will notice it's very helpful. And all physical products that you see around you, any physical product that you can touch, was first built and drawn on a computer. And it was modeled by using these constraints, this constraint feature we talked about here. So if you watch the video, you'll also see how that slider in the video is constrained, all right? So anyway, so that's the, that is the application of what this is useful for, functions and graphs and coordinate geometry, okay? So today, before we jump into that though, I want to ask you guys a couple questions. Have you been taking down the notes of what we've been going through? Have you been keeping your own pure notes? So yes or no? Good, most of you have. So this will be actually quite helpful. We're doing the Cahoots today and we're doing a revision of the older stuff because there's a big piece I want to touch on. This piece is called spaced repetition, okay? So before I introduce this, can you put down into chat, if I tell you a number today, let's say I tell you a 2-digit number, like 14, how many days do you think you can remember this number? So put that down into chat. More people are saying 1 week. Okay, most of you are saying 1 week, a few days. Some people are saying forever, okay, good. So this, again, this is not a matter of like, oh, I can remember this for longer than you can. This is not a competition. The point is everybody has a different number for themselves. Actually, most people don't really know what that number is. And you can think about this, a good way to test this is when you change birthday, like when you grow older, after your birthday, if somebody asks you how old you are, sometimes, you know, for like a week or so, you have to think about it. And you forget, it's like, oh yeah, I actually just aged, I'm a year older. Or in New Year, like when you write down the date, sometimes it takes time for you to remember that the year has changed, right? So our brain also takes time to remember new things. And for everybody, it's a different amount of time. And so what spaced repetition is doing is it's a very efficient way of learning. And in essence, what this is let me show you on a graph. Let's say today you learn coordinate geometry, okay? And so this x-axis is time. So what happens is initially you've learned it, okay? So here is mastery, and here is don't know, okay? So for some time you'll have remembered it, and then you'll start forgetting a little bit, forgetting a little bit. And if you don't revise it, you'll have totally forgotten it after a while, okay? But then if you try to remember it again after this point, then you essentially have to relearn everything. You essentially have to go through the same amount of work that you went through in this region here. The same amount of work needs to happen again, okay? So what spaced repetition is doing is it's saying, okay, well, instead of revising here, you revise earlier, you revise over here. And therefore, to go back to mastery, you only need to do a little bit of work. Only this much work needs to be done, correct? So less work needs to be done. And what you'll notice is if you revise it, then you will remember it for longer. And then the gradient of forgetting will be lower. And then again, you will revise it again over here. Let's use a different color. And so again, you will remember it again, okay? And then the gradient will be even lower until after maybe 4 or 5 of these, you actually will remember it forever, right? Will you ever forget your name? You won't forget your name, right? You won't forget your name because you've done it so many times in your life. I could wake you up at the middle of the night and you'll remember it. And the thing is, you've been practicing what your name is every single day. So the space repetition aspect is, what is the space? This is the space here, okay? And this is bad space. So the idea is, let's say this is good space and this is bad space. Let's make this red actually. The idea is that you are practicing what you learn in such a manner such that you maintain mastery on it with very little work. Okay, so does this concept make sense? Yes or no? Relaunch poll. Most of you it makes sense, some of you not. So practically what this means is, let's say today is, what's the day today? Today is Tuesday. So Tuesday, Wednesday, Thursday, Sunday, right? What practically this looks like, and which I would like you to do, Sunday, Monday. So if today you learn, if you learn something, then I recommend revise it tomorrow, right? Then leave a day, then revise it. Then leave 2 days, and then revise it. Okay? And what you will notice is this revision, and this revision will be very little. And what this actually means is just reread your pure notes. Okay? Same thing here, just reread your pure notes. Oops. And by doing this, then leave like even more days. So then over here, you'd leave 1, 2, 3 days. Or you can follow a Fibonacci sequence. So you can do 1, 1, 2, 3, 5, 8. Fibonacci is when 2 numbers add up to the 3rd number. So any 2 numbers in the sequence will add up to the next number. So the next number here would be 5 plus 8, which is 13, right? And the next would be 21. That's Fibonacci. So you can also follow that sequence. But this is the practicality of spaced repetition. So that's the reason why today we're going to go over the Kahoot, because I don't want too much time to pass between when we first learned the concept and when we're applying it. It has to be pretty soon. So to make sure that you remember it still, okay? So we'll do this in the middle of class today. So let's jump in and let's actually learn something about straight line graphs, and then we'll take a break with the Kahoot. Straight line graphs are probably the things that people confuse the most. Like this is probably one of the interestingly, the hardest topics you go over, or the thing that people take the longest to understand. So that's why we're going to go over this. And we'll give you some SAT questions, before this. But okay, so what we need to understand in this is that notice how this color of X and Y is different, because these two are variables, okay? And M and C, these are constants. Okay, that means now it is very important that you understand the difference between this variable and constant. It's actually one of the more complicated things, because on this graph here, the value of X can be anything on this line, right? And the value of Y can be anything on this line. It is never fixed, okay? But the values of M and C, they're fixed values. So if I give you this line here, the values of these lines are fixed. M and C is fixed. However, we may just not know it. So in other words, these are constants, but also unknowns. Okay, so this is important. So the values of M and C are fixed, but we don't know them. Never are the values of X and Y fixed. X and Y are never fixed. They're always, they can change. Whatever point you choose on this graph, there will be a different X value and a different Y value, right? It's very important to understand that difference. Okay, so once we have understood this, now let's take a look at an interactive graph that's very important for you guys to understand. So it's really important to understand what the straight line graph looks like, okay? So you will see here we have a straight line graph in blue, and on the right side here we have M values and C values that can change. So if you're also on the website, I would like you to go ahead and play with this also. Try moving this left and right and see what happens, okay? So what you'll notice is as my C value gets larger and larger, my X value, my Y value increases, right? The graph increases. So my C value is lower, so this is intersecting at this point here for C equals -4, right? And as I increase C, this graph goes up. So notice this trend. As I increase C, this graph moves up, right? And I'm doing this, like, folks, this is so important. I know this may sound simple, but it's so important to get an understanding of these graphs visually, able to visualize in your head. If you close your eyes and move the value of C, you should be able to move the graph up and down. This will make such a big difference in your understanding of these equations, all right? Same thing for M. If I make my M larger, it becomes steeper and steeper. And if I make it my M smaller, it becomes less and less steep until if my M is 0, then it's a flat line, right? So again, I want you guys to close your eyes and visualize. If it's negative, it becomes steeper and steeper negative the lower I get, or the absolute value increases, or essentially the more negative I get, the more steeper this becomes, all right? And you'll notice we have this very nice triangle that's shown here, this triangle piece here. This is essentially showing the gradient. And so in your things to memorize for today, what's happening? Yeah, in your things to memorize today, you will see that the slope formula is shown here. So this will help you understand. Now you can close your eyes and really see what does it mean to be rise over run, okay? So that's the straight line equation. Now let's move on to parabola. So parabola, same thing. So parabola is interestingly can be shown in 3 different forms. It can be shown in this, what do we call this? The factorized form. Factorized form. It can be shown in the completed square or vertex form. Okay, yeah. Or it can be shown in this form, which is its original form. Okay, so I want you all to understand what happens to the shape of the graph as you change the values for every single form. Okay, so you will see on the right side here, the standard form and the completed square form are shown. So let's take a look at what happens if you change the value of A. So A is, this is A right here. Okay, so it's the coefficient of x squared is A. So if my A is positive, the more positive it becomes, the narrower it becomes. And the more negative, if it becomes negative, you will notice this graph becomes upside down. Okay, so again, visualize, don't memorize this, visualize this in your head to understand, okay, if A is negative, it's an upside down parabola. If A is positive, it's an upward opening parabola, okay? I want you to, again, understand this in your head. Just understand this in your head, okay? Then let's take a value, let's look at B. So what happens to B? If my B becomes more negative, then it goes lower, okay? If my B becomes more positive, it goes lower on the left-hand side. All right, just understand this visually. And you may be interested to notice the minima at this point. Notice how it's moving in a upside down quadratic shape, right? Pretty cool, right? I'm not sure if you're seeing this, but the minima is moving in an upside down quadratic shape. So there's pretty cool math behind this. And you will see how this changes the completed square and the standard form as well, okay? And then the C value, which is this value here, if you change that value, it just moves up and down. Same thing like the straight line. Okay, so it's important that you understand this. Now the vertex form is important. The vertex form is important because you can read off the root. So in this diagram right now, sorry, not the root, the minima. The minima is at -6, and I think about -1 or so. Yeah, so you will see that in this completed square form, let's go here. So this is around, this is around -6, and this is around 1, right? So this is around -6, and this is around -1, right? So you will notice here that the sign changes for the answer. So if it's positive 0.86, then this becomes negative 0.86. And if this is negative 5.84, this stays as negative 5.84. So therefore, what we'll do here is you will notice there's a negative sign here, right? You'll notice this negative sign. This is what this negative sign means in this. This negative sign just means that if you increase b, then the root goes more and more negative. Okay, so I like to see this more visually, and I can change this to red. So I better know, like when I am able to commit this to memory, I know that if I increase my b value, my minima will move more and more left. Okay, if I increase my b value, notice how my minima is moving more left, right? And if I decrease my b value, my minima moves more and more right. So that should help you understand. That's why there's this negative sign here, okay? You will also notice there's a negative sign over here. So let's make this red as well. Why is a negative sign here? Because the root is also the opposite. So if in this equation, let's see, how can we make this even? Let's change it here. Okay, so in this equation, if x1 and x2 are my roots, then my equation will actually be x minus x1 times x minus x2, right? So it's a negative, it's opposite. So that is why the negatives are there. Is everyone with me so far? Yes or no? If there's any questions, you can put that down in chat. There's an interesting question. Why does this curve move in a parabola? Why does the minima move in a parabola? That's interesting. Try and see if you can do the math yourself. What do you learn? I would love to know. I actually didn't try to do the math, but I think it should be pretty simple to do this math to figure out why it moves in this negative parabola. Okay, awesome, good. Right, so people are with me. Super. Yeah, so actually it's this one that matches exponential function. Good, okay. So let's now do a couple practice questions with these. So we're actually gonna do practice questions from the SAT. The SAT has some really good practice questions on here. So this is paper 8 from Khan Academy. And let's see what you are able to put together. Okay, so I would like everybody to take some time and do question B. So take a minute to do that. Yeah, this is pretty straightforward, right? So if you're making a mistake, that's amazing. Well done. Quite a few of actually are making a mistake. So what this is asking for is which of the following is an equation with a slope of 3? So in y equals to mx plus c, the m value is the slope. So this has to equal to 3. So over here, the coefficient of x is 1 over 3, so this is incorrect. The coefficient of x here is 1, so this is also incorrect. The coefficient of x here is 3, and so therefore C is correct. Okay, so slope equals gradient, and gradient is always the coefficient of x. And again, if you got this incorrect, you should be so happy because you've learned something, right? So we're learning something here. So well done. Actually, let me just leave this here. Good, okay, so now that we have this knowledge, let's try this one. We're gonna do number 9. Let's do number 9 now. I'm gonna relaunch the poll. And if you're getting these incorrect, update your peer notes, write something down in your notes that helps you understand this better. Okay, so you'll notice this is slightly related to what we did in mensuration. One thing I would like you to notice is if you usually make mistakes in reading questions, SAT challenges you a lot. Just make sure you know that they're looking for centimeters and centimeters, okay? So essentially they're saying the volume equation is here and they've given you this volume here, okay? So what you do is 7 pi k cubed over 48 is equal to 473, right? And then you just solve for k. And I think the answer should be B for this one. Okay, let's do 10 now. Let's do 10. Just be careful with 10. 10 is a little tricky. Okay, all right, so most of you have answered. So this one is tricky because actually this answer is incorrect and this answer is also incorrect. right? Yeah. So think about if you got either A or B, which is actually the most common answers were A and B. Think about this again. Why are these two incorrect? Yeah. So let me show you in a separate drawing. Let's say we have this, okay, and this is broken up into well, what is happening here? Let's say this shape is broken up into 1, 2, 3 boxes. Okay, and let's say at every time, I fill up one box. So one box is filled time 1, 2, 3, and then maybe this fills up till here, right? What you will notice is it took me 3.5 to fill up till here. Now I do 1, 2, 3, 4. So now it takes me 4 units to fill this up. 1, 2, 3, 4, 5, 6. This takes me 6 units to get up to here. 1, 2, 3, 4, 5, 6, 7. Now it takes me 7 units to fill up to here, right? So it's taking me longer and longer to go up 1 unit. So time is moving at the same pace, but it's taking me longer and longer to go up each unit on this graph. So what that means is if we zoom in here, right? It's taking me longer and longer to fill these up on this time axis, right? The distance here is increasing. First, it's only this big, then it's this much bigger, then this is bigger, and this is far bigger, right? Because of this shape, because this is open upwards, right? Now these are tricky. SAT is quite tricky. It's for people that are just finishing up JCs. Usually do the SAT, so it's fine if you're getting these wrong. Again, it doesn't matter if you get this right or wrong. What matters is are you learning? Okay, that's the main focus. So are you learning? Good. All right, let's do another one. Let's do this one. Let's do number 19. So 19 is very similar to actually what you will find on your O-levels. So really think about this. So let's do this now. Let's read this one by one. So it says the range of polynomial function f is a set of real numbers less than or equal to 4. So this is what we need. So what does less than equal to 4 mean? The range is less than equal to 4. That means that y is less than or equal to 4. So if we take this first graph, and this is 1, 2, 3, 4, that means our answer lies in this region somewhere, right? Same thing here, 1, 2, 3, 4. Our answer lies in this region. We can cross out this one because 1, 2, 3, 4. There is a solution outside the region, right? The graph exists outside this region of ours. And so that's why we cannot, this does not make sense. So this one is incorrect. Here again, 1, 2, 3, 4. Again, this exists outside the region, so we cannot have this one. So this is also incorrect. Now, within these two, let's focus on within these two. We have zeros is -3 and 1. So notice here they have -1 and +3, and here they have +1 and -3. So if you remember, if we go back to our notes, right? If you go here, you will remember the graph is these values are red, right? So it's the opposite. Let's go back to SAT. So because it's opposite, that means that if the roots are at -3, the function would look like, the function would be x plus 3 and x minus 1, right? This is the function. However, on the graph, the root will still be at x equals to -3 and x equals to 1. So therefore, the answer is A. Okay? Your function is opposite, but your answers are still -3 and 1. All right? This is a very important thing to know. So if you got this one incorrect, hopefully this helps you understand that better. So this question is really good because it really helps you understand, like, what does 3.39 mean, right? That's what they're asking for. Where's 3.39 million? It's very important to understand this conceptually. It's very, very important. 3.39 in this equation, this is the gradient. You match this with y equals to mx plus c. M is the gradient, right? And gradient is, whoa, what happened? Gradient is equal to rise over run. Or in other words, the gradient is the rate of change, right? Equals to the rate of change. So let's take a look at this. This is amount of plastic produced during 1985. This is not correct. This is not a rate. We're looking for a rate. This word is very important. Gradient is a rate. But this is amount, so therefore it's not correct. Here it's number of years to produce 1 billion. So, okay, interesting. So number of years, which means number of years here to produce 1 billion. This is also incorrect because this is actually, this one is saying run over rise. Right? Number of years is the run and amount is rise. And this is saying number of years to produce 1 billion. So it's run over rise. This is also incorrect. A lot of you said this, average annual plastic production in billions of pounds from 1985 to 2003. So from 1985 to 2003. Wow, okay. How do we do this? 15, okay, I guess up to here. This is, again, this is average, wait, hold on. Yeah, okay, so this one is average annual plastic production. But the key here is it's annual. So notice this key piece here, average annual. So what this means is that this is saying it is production per year, right? So it's here, this does look like rise over run. Production amount divided by years, right? And this says average annual increase in billions of pounds of plastic produced per year in the United States from this to this. This is average annual increase. So this is increased production per year. So let me do this poll again. Now that we know this, between C and D, which one do you think it is? Is it production per year, the average production per year, or is it the increase in production per year? Good, nice, okay, excellent. All of you getting it. It's the increase in production per year, correct? Because M is, in this diagram, it's this piece here, right? This is M. So M is this increase. The average of this would be somewhere around 80. 80 would be the answer for C. So that's incorrect, right? It's the average increase. Good. All right, let's do one more and then we'll jump into the Kahoot. Let's do this one. It's okay if you're not getting this one, but there's two things that when you're faced with a problem like this, which is quite tricky, there's two things you can do. The first thing, always draw it out. Right? We really focus on visualization in this class, and visualizing just helps things so much. Okay, so if we have a line here, then let's draw in what does y equals to x plus b look like? Well, this won't be it because there's a constant, right? So let's do this, right? The gradient again is 1. We know the gradient. And then let's see, what is the line for, let's do green here. What is the line for 2x plus b? So the gradient will be a little higher, but b is the same. Notice how b is the same. So it will still come through this line. So the gradient will be 2x. So this is 2, right? The gradient is 2, and this point here is b, right? If you got this much, then you are in a good shape. Your basics are good. This much is absolutely needed. Y is equal to 2x plus b. Okay, this much is much needed. All right, now we know that PR, so P, if this is x, this is x, and this is y, there exists some P here and some R here, correct? Or actually, let me move this P in. Some P here, some R here, where this meets this on the point here, right? PR is on the first line. And 2P and 5R, put 5R here, meet on this line somewhere here. Okay, interesting. You get the point, right? You get the point, like it meets at this point. Anyways, okay, good. So if you've drawn this out, I know this is not directly related to the question, but if you draw this out, that means you have a good understanding of what is B, that B is your intercept. What is the gradient? You can read off the gradient from the equation, right? The gradient here, and you know what this looks like. Now, what is R over P? Essentially what you do is you plug it into the equation. So PR, so P is X, so P plus B is equal to R, and then 2P and 5R, so 2P times 2 plus B is equal to 5R, all right? And then you just rearrange, and you rearrange for R, you rearrange for B, you find B, and then you do R over P. Anyway, the answer you should get is B. I won't go into the arithmetic. That's, again, not the focus of today. The focus of today is that you were able to get this, and you were able to get this, okay? If you did not get B, that's okay. As long as you got this portion, it's okay. I would, however, write down what's the root cause of your error. Did you mess up P and R? Did you, like I did here, were you not able to draw it? Did you mess up the arithmetic? And whatever your root cause of the error was, practice that specific error, okay? All right, cool. So I think we are all ready for a Kahoot now. So let's do this Kahoot for today. So in this Kahoot, we're going to be revising differentiation. So if you're eMath, you can just guess those answers. Unfortunately, I can't split differentiation and non-differentiation. We're going to do circle theorem, and we're also going to do mensuration. Okay, so have all those pure notes ready, because those pure notes will be needed for this one. All right, so let's jump into it. So spaced repetition of these stuff. Cool, all right, so to do this, you had to go to mensuration, and if you go down to shapes, this was using this equation. So if you use this equation here, you would have gotten the answer. You have the dimensions you need, right? You have the base dimension, the top base dimension, and the height. So you just plug into this equation here. All right, if you got this one wrong, put this down in your notes and make sure you revise this, okay? Make sure you review these notes. Having them here on the website is not helpful. These need to be in your head, right? So make sure you review it. All right, we've got a leaderboard. I don't like the leaderboard. Let's keep going. This is a differential question. Again, I'm sorry if you're eMath. I couldn't split this up, but if you go to further differentials, to do this, you would use this rule here. This rule down here, okay? This is the rule. All right, interesting, okay. So to do this one, you should notice that this is an isosceles triangle. So therefore this angle is 30 up here. So if this is 30, then this is 180 minus 60. So this is 120. If this is 120, then, and this is 80, that means this is 160 over here, right? 360 minus 120 minus 80. So this becomes 160. Therefore, this ends up 10. This is 10, because if this is 160, these two angles are the same, all right? So the answer is 10. Interestingly, most of you got 15. That's quite interesting. I wonder why. Did you just divide 30 by 2? Can you put in the chat what happened? Just divide 30 by 2? Yeah, interesting. 10, good job. All right, so write down, you should be able to write down like what went wrong. Find out the root cause, okay? Notice that these are isosceles triangles because the radius is here. It's a differential question. All right, well done, well done. Most of you got it, good. So for this one, you just had to use, what was the question? Cosine, so you had to use the cosine version, which is here, all right? Again, I really prefer this function, this method, because it shows you that, it shows you the chain rule built in, right? That's why I prefer this one. Good, well done. All right, okay, well done, well done. Most of you got this. So to do this, you had to notice that if you take these two, well, if you take this point and this point fixed, then this angle and this angle here is the same. So this is 24. And then because it's a cyclic quadrilateral, this angle and this angle are complementary. So 24 plus 48 is 68. And then 180 minus 68 gives you 112. Yeah? Good, all right. Quick question for the, let's go here first. All right, nice. And then let me ask you this question, which is, does it matter who wins this Kahoot? Yes or no? Does it matter really who wins this Kahoot? Interesting, okay, so 75% of you say no, but 25% of you say yes. Okay, maybe it matters. What, can you put in the chat, what matters more than winning this Kahoot? Understanding, good, yeah, somebody says understanding. Somebody says understanding concept, good. Knowing your fundamentals, learning, good. Revision, good, exactly. Those things matter so much more, right? Those things matter so much more. And if really, like, if you're in this call, like this Kahoot is the most important thing for you right now, then just pause and think about this. Like, will this really be as impactful in your life? Or can you have fun even if you're not in the top 5? Can you still enjoy this process if you're not in the top 5? I just want you to think about that. All right, let's keep going. So TVU. Nice, well done, well done. This one was a tricky one. So if you take these 2 points, you will notice that this triangle and this triangle are the same. So this is also 52. You will also notice that this line and this line are parallel, right? Therefore, you have the Z shape here. So this angle is also 52. So this is 52 and this is 52. So you can do 180 minus 104 to get this angle. And then this would be the same angle as this, right? So 180 minus 104 is 76. This is also 76. Well done. Good, good, good. Good, okay, yeah, you just use this rule over here. It becomes a cosine and you take the f prime of the inside. So 2 comes on the outside, 2 cosine 2x. Good, 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 well done. Okay, so this one is just pi r squared, r is 12, pi r squared, area of the entire circle, times 45 divided by 360, right, to get the sector here. So pi times 12 squared, so pi times 114 times 45 divided by 360. Oh, is the answer incorrect? Is it supposed to be 56.54? Okay, interesting. Yeah, okay, my apologies in that case. Okay, good, all right. Hopefully you didn't pick any of the other ones, which are too far away from that. We'll change that. TUS. Interesting, many people picked 72. Interesting, so you guys drew the Z shape. Remember, the Z shape rule only works if this line and this line is parallel. In this case, we don't know if these 2 lines are parallel. Therefore, this Z shape does not work in this case, right? We have to try something else. So what we realize is this line and this line are the same length. So this is another isosceles triangle. So these angles here are the same. So 180 minus 72 divided by 2. So this becomes 108 divided by 2. So this becomes 54. If this is 54, then this is 54. And we also know if we take these 2 points, then this triangle and this triangle are the same. So this is 72. So 54, 72, U also has to be 54. All right, good. So if you messed up, if you got 72 for this, remember, put this down in your notes and review this tomorrow. That this only works if this line and this line are parallel. Good, good. So you have to use this rule here, exponential. So the exponential stays the same on this side, and it's just the differential that gets multiplied with it. So the differential of this function is just 3. So 3 times this entire thing. That's the answer. Good. Ah, interesting. Okay, between 65 and 55. All right, so let's take a look at this. So if this is 65, we know that this angle is also 65, correct? Because of these 2 points. This triangle and this triangle are the same, so this is 65. That means this all becomes 65 plus 50, which is 115, right? Is it? Yeah, 115. And because this is a cyclic quadrilateral, these two have to be the complement of each other. So if this is 115, this is 180 minus 115, which is 65. 180 minus 115 is, yeah, 65. Yeah. Okay, so that should help you get there. How did many of you get 55? I'm not sure. But if you followed a different approach, think of what's the rule that you missed, or was it an arithmetic error? Take a look into that and make sure you, oh, somebody typed the value incorrectly into the calculator. Ah, interesting. So keep a note of that. If you made that mistake, then just make sure you keep a note of that. Whenever you make that mistake, keep a note of it so you know how often do you make that mistake. And so you know if you need to address that in the future. This is awesome. Oh, this is awesome. Blue was false and red was true. So though this question was easy, blue was a false one, red was a true one, if that's the mistake you guys made. It's really, again, I can't stress this enough. Reading the question properly is so, so important. And this Kahoot adds a sense of speed, and the test will have the same sense of speed. So you will know the material, but if you don't read the question properly, you may end up making mistakes like this. So it's very important you do not let the time pressure get to you, and you still keep reading the question properly, and don't take shortcuts, like assuming the color to be the answer. I'm sorry, this was so evil. This was so, so evil. I'm sorry I did that. But now we know. All right, last one. Nice, good. So this is looking for the arc length, so 2 pi r. So 2 pi times 12 times 45 over 360. All right, I don't really want to show you the end. All right, hopefully that was fun. I want to stress this aspect though, like it really does not matter who wins or who loses in this. It really, the idea is, did you have fun through the process? Were you enjoying those 16 questions? If your enjoyment is only tied to winning or losing, then in this game, if I have a bunch of students, only 5 people will be happy, right? If we have 100 people on this call, only 5 people will be happy. So I don't want that. I want all 100 people to be happy. So I want to do these Kahoots only if you promise me that you're enjoying during the Kahoot and not only by winning or losing, okay? Winning or losing really doesn't matter. Here you are learning math with Kahoot. That's pretty cool in its own, right? So enjoy that process. Have fun in that process. Okay, so well done. With this, we did a lot today. So for those of you that are in eMath, you can drop off now. Cool. So the last piece that we're going to go over is circles. So let me just set up my iPad for that. And then I will share my screen, and I just want to go over the visual part of circles. It should hopefully make the practice that you do later on a lot easier. Okay. So in the circle formula, when you have a circle, we need to understand where the circle formula comes from. Like, don't just memorize this. Understand this, and it will help you in your ability to memorize. So what you'll notice is that the circle is always some distance r from the center. Okay, like around the clock, it's always this distance r from the center. So we know how to calculate the distance r. If this is x and this is y, then r is equal to, sorry, r squared using Pythagoras. What am I doing? R squared is equal to x squared plus y squared, correct? So this is the most simple equation, most basic equation to get the formula of a circle that's at the origin. Okay, so for a circle at the origin, this is at the origin, this is the most basic formula. All right, and it makes sense how we got here using the triangle function. Now what we want to know is, how can you change the x value such that this graph moves left or right? Because we want to change this across x. So to understand this, let's come down here to this, create this one tool here. Okay, so in this equation, we have, it's weird, the naming is weird over here. H is being changed for the x value, so it's changing the x value, okay? So if I increase h, you will notice it moves right, but it has a negative sign again, this negative sign, right? So just notice this negative sign. If you remember the negative sign, that's good. If you don't include the negative sign, then essentially it's opposite. So what we'll do here is come back and we'll change this to red, okay? And the same thing happens to the y value. I'm showing you this because it's important to remember that the a and b values are red. As I move this up and down, this equation here, the negative makes a big difference, right? Notice the negative on the bottom left. Notice this negative here, here, and here, okay? So to remember this, as you change these values, it's up and down, but if this negative was not there, it would be flipped. Okay, so maybe we can update this tool to have it flipped in the future. But this is essentially how the circle form comes about, because you are changing the x and y values by this b value or a value. So in here, we're changing x by negative a, and that's how you're moving it. And over here, you're changing y by negative b. Okay? That's how this comes about. Now, to get an understanding of how these questions are used, I just want to show you that sometimes they will give you a circle like this, right? And they will say that there is a tangent over here. Okay, so just know that the perpendicular, using the circle rules, you should remember that the perpendicular to the tangent goes through the center. Okay, so let's put this in the center. Yeah, the perpendicular to the tangent always goes through the origin here. So sometimes you will have the equation, like let's say this is 3x plus 2, then, and it gives you this point here as 1, 1. Then you know that the equation of this tangent is the gradient is the negative reciprocal. It goes to negative 1 over 3, right? It's a negative reciprocal of this gradient. The gradient of the green line is a negative reciprocal of the gradient of the orange line. So your new line will be y is equal to negative 1 over 3 x plus c. And you have this point that this goes through. It goes to the point 1, 1. So you can put 1 is equal to negative 1 over 3 times 1 plus c. So c is equal to 1 plus 1 over 3. Okay, c equals 4 over 3. So the green line is equal to y is equal to negative 1 over 3x plus 4 over 3. Okay, that's the equation of this line. They will ask you to do this pretty often, actually. So now you know how to do this portion. If in any of this, let me close this up. If in any of this, if the negative reciprocal was the issue, then write that down and practice this. If this piece of solving for the equation was the issue, then write that down and practice that portion. This does not mean that you are not good at coordinate geometry as a whole, or you're not good at circles and tangents. No, all that means is if I give you a point on a line and the gradient, can you find the equation of the line, right? That's what this portion is here, or actually all of this. If I give you a line with a point on it and its gradient m, can you find the equation of the gradient? That's all this is. So break this down, decompose this into the smaller pieces, and work on the piece that you need to work on. So then you will also notice that this point also goes through the center. Let's say this is -2, or sorry, let's say this is 2 and -2. Okay, then you don't even need this point because you'll notice that it goes to the center. So you can use this different point here. So that would be this value and this value would change, right? From 1, 1, it would change to 2 and -2. Same thing, you would still get the same equation. And then what you can do is you can calculate this intersection here by equating this equation and this equation. Okay, so what that would look like is you have -3, 1 over 3x plus 4 over 3 is equal to 3x plus 2, right? And you can solve this for x equals something, and then you plug it back in and solve for y, all right? This is how you can find this point of intersection. I just went over the theory here. You guys can practice this on your own. We put practice questions online, and also the 10-year series goes through many of these. But the fundamental piece is that even this step here, so this step here, or sorry, this step here was equating two equations. If I give you two straight lines and equations of the two lines, can you find me the intersection? Right? Can you find the intersection for me? So to summarize this, what I want you to do is draw out this graph, which is, in this question, if the question asks for a circle and a tangent, and it says center is at 1, 1, and the tangent is f of x, okay? The question is, what is the point of meeting between tangent and circle, right? Basically, what is this point, question mark? If that's the question, what I want you to do is break this down into this following diagram, which is first, what you have to do is find gradient of perpendicular to f of x, okay, which is this line here, right? Then 2, find c value of perpendicular using center, right? So you have the m value, which is a negative reciprocal. You have the m value, and you know it goes to the center, so you can find the c value of y is equal to mx plus c, right? You can find this value here, all right? Then let's go back to this color, 3. Equate f of x and perpendicular f of x, right? Equate this and solve for meeting point. All right, so this is how you would approach this question. The thing I want you to take away from this is that these are 4 different steps, all right? Sorry, 3 different steps. In these 3 steps, what are you struggling with? Where is your issue? Wherever your issue is, practice only that step. Get better at that step, okay? So does this make sense, this last piece? Does it make sense, like what I'm trying to do here? I'm decomposing a bigger problem into its smaller pieces of what you're going to do. And I'm helping you figure out, if you make a mistake, at what step did you make that mistake? And then practice that step. Because in all, this question is not that difficult. It's only difficult because it's stringing together multiple steps, okay? All right, awesome. So we are at time. Yeah, equate means doing simultaneous equations. Good question, yes. When I say equate in step 3, I mean simultaneous equations here. Simultaneous equations. All right, so well done. This is all I have for today. So let me send you out with some more awesome Harry Potter theme. And I will not be sticking around today because we are at time, but if there's any questions, you can feel free to email me, all right? So music coming up in 3, 2, 1, it's gonna be loud.